All right, hi guys, welcome to our first e-learning seminar instruction. We are going to be learning about Pythagorean theorem, going into right triangle trigonometry. This is one of your big rocks for Algebra 2 this year. As you guys just saw on the ACT, there was a lot of trigonometry, sine, cosine, and tangent. So if you guys do retake the math section in September, or any time between now and the end of your senior year, this should be really beneficial for you guys. So before we dive into Pythagorean theorem, we're going to review parts of a right triangle. So A and B are what we call the legs of the triangle, okay? It does not matter which one you label A, which one you label B. So this could be B, this could be A if we wanted them to be. It does not matter. What does matter, though, is that side C is the hypotenuse. The hypotenuse is the longest side in a right triangle, and it is always directly across from the right angle, okay? So as long as you're looking at a right triangle and you label C correctly, it does not matter which one you label A or B. The reason it does not matter which one A or B is because we use the Pythagorean theorem to find a missing side length on a right triangle, and our formula is A squared plus B squared equals C squared. So because it's A squared plus B squared, that's why it doesn't matter which order you label them, because we know that 2 plus 3 is the same thing as 3 plus 2. Doesn't matter the order that you do it in. So we label our side lengths A, B, and C. We plug them into our formula, and then we solve. So proving right triangles involves taking an A, B, and C value and plugging it into the formula and seeing if it creates a true statement. Does the left side really equal the right side? So you might be wondering, if we're not looking at a picture of the triangle, how do I know which one is A, B, and C? Since C is always the longest side of a right triangle, if I'm looking at 3 numbers, I know that C has to be my largest side, okay? So find that largest side first, label it C, and then what you label A and B afterwards is up to you. So the first thing that I'm going to do is I am going to plug those into my formula. So I'm going to say 8 squared plus 15 squared equals 17 squared. And I want to know if that is true. So I go over to my calculator, I type 8 squared plus 15 squared, hit equals, that equals 289. And then I type in 17 squared, which also equals 289. And that is a true statement. 289 does equal 289. So we say yes. Oop, not yes. Yes. That is a right triangle. So now I'm going to continue and I'm going to try the same thing. So again, I find my largest side. That one has to be C. And then 5 and 9 can be A or B. So I check, does 5 squared plus 9 squared equal 12 squared? So I check, does 25 plus 81 equal 12 squared, which is 144? It does not. 5 squared plus 9 squared is 106. 12 squared is 144. This is not true. And so we say, no, not a right triangle. So then we continue on. I've got my C, A, and B. And then again, the cool thing about this video, guys, is that you can pause, you can rewind, fast forward through certain parts of it. So if I'm moving too fast or you need to see something again, just utilize those features and, help you. So A, B, and C, I've got 7 squared plus 24 squared. Does it equal 25 squared? The answer is yes. We get 625 equaling 625. I think, actually, let me check. Yeah, we're good. And then find my C, label A and B. A squared plus, oops, not B squared. We actually have B. Plus 14 squared equals 18 squared. That gives me 296, and 18 squared is 324. So this one was a yes. Sorry, I forgot to label it. And this one is no. So that's what it means when it says proving right triangle. It's taking an A, a B, and a C value and plugging them into this formula and looking for whether or not you get a true statement. Does the left side equal the right side, and vice versa? So now, using Pythagorean theorem to find a missing side, okay? Since I scrolled up on the screen, I'm going to rewrite our formula over here, so we can always see it when we're working on these problems. If you look at your steps on the side, we do not have any radicals to simplify, so actually I'm going to go ahead and say ignore that part right now. Right now we're going to label our sides of our triangle, okay? So I know that the side across from the hypotenuse has to be C, okay? If you struggle with finding the side that is across from the right angle, you can always take your pencil, and now bear with me because I'm going to try and draw a pencil. You can put your pencil over the right angle with the tip of the pencil going right into the angle, and then whatever side that your eraser is touching, that's considered your opposite side. So hopefully you guys can see that that's a pencil. That's a trick that I show my kids in class to take, and if you're watching this on a computer screen, it still works. Take a pencil, pen, Sharpie, whatever, put the tip of the pencil inside the right angle, and the side that the pencil is touching or where the eraser is pointing, that is your opposite side. So if the hypotenuse is opposite of the right angle, you can use that one to find it. So once I label C, then it doesn't matter what I label A and B. I'm just going to say that this one is A and this one is B. And so I'm going to plug them into my formula. I have A squared plus B squared equals C squared, which gives me 8 squared plus 7 squared equals C squared. So you can do that individually. You've got 64 plus 49. You could just type that all the way in on your calculator if you wanted to. 64 plus 49. And we get 113 equals C squared. And so now, if we're looking at our triangle that's got side lengths 8 inches and 7 inches, it doesn't make sense that our hypotenuse would be 113 inches. That's really long compared to the other two sides. And the reason that that's really long is because that's not our hypotenuse. That is our hypotenuse squared, okay? So if we want to find out what just plain C is, because if we look over here, our hypotenuse is just C, not C squared, then we have to undo that square, okay? So remember back to chapter 5 when we learned about rational or radical equations. The only way to undo a square is with a square root. So whatever I do to one side, I have to do to the other, okay? These cancel out, square and square root cancel out. So I get that C equals the square root of 113. So I type that in on my calculator, square root of 113, and I get 10.6, okay? If you want to if you want to simplify that radical, then you would use the steps on the side. Is 113 divisible by any perfect squares? And if it is, then we rationalize it. So we check, does 113 divide by any of these numbers? I'm going to check 81. Nope. I'm going to check 64. Nope. I'm going to check 49. Nope. Checking 36. Nope. Checking 25. Nope. Checking 16. Checking 9. And checking 4, just for good measure. So nope, it does not have any perfect squares, so we cannot simplify the radical, so we leave it as 113 or 10.6. And then lastly, we have example 6. Same thing, I'm going to label my sides. I'm going to do this one a little bit faster now. Again, pause, rewind, do whatever you need to do to be successful with this video. Label C. Label C. Then label A and B. Plug them in to your equation. And then solve. So we get 225 plus 18 squared, 324. So 549 is c squared. Again, that number is way too large if our sides are 15 and 18, meaning we have to square root that on both sides. And so I do the square root of this number, 549. And I get 23.4 equals C. If you want to try these steps over here, it says how to simplify a radical in your calculator. Take the number, type the number without the radical, divided by x squared. Click second graph to look at the table, and look for your last whole number pair before 1 point something. So I can show you guys that because I've got my calculator. Once this add passes. So my calculator, it says go to y equals, type in 549 divided by x squared, and then second graph. And again, this app I've linked to your Google Classroom, so hopefully you guys can see it. And we're going to scroll down, and we're going to find the last whole number pair before 1 point something. So I don't see any whole number pairs. So 3 and 61. So that's our simplification. So we're going to say 3 root 61. 3 root 61. Both of these are correct answers for C. Okay, so those are our Pythagorean theorem notes for today. Again, pause, rewind, play this video back. You guys have a target to complete online. Otherwise, it's attached at the end of the packet. So email, remind, text, Google Classroom, ask if you have any questions, comments, concerns. I miss you guys. I hope you guys are staying safe. And let me know if there's anything else